were poorly equipped and underfunded, and that the civilian-led Atomic Energy Commission and the Air Force did not coordinate their efforts effectively. The National Archives at Kansas City hosted this hour-long event.
Tonight, it's my pleasure to introduce Dr. John Curatola, who is an Associate Professor of History at the U.S. Army Command and General Staff College at Fort Leavenworth, Kansas. Prior to this position, he was an active duty Marine Corps officer and retired in 2009 as a lieutenant colonel after 22 years of military service. He received his doctorate from the University of Kansas in 2008, and his work has been published in a number of books and periodicals. After the program this evening, he will have copies of his book that he'll be speaking about this evening available for purchase and signing. Please give a warm welcome to Dr. Curatola.
Thank you, Kimberly. I appreciate the introduction. Some of you are probably wondering, what's a Marine doing talking about nuclear weapons and bombs and that kind of thing? And I must admit that growing up as a child, I'm just a frustrated B-17 pilot who happened to join the Marine Corps. So that's kind of my background. The title of my book, Bigger Bombs for a Brighter Tomorrow, is not something that I thought of. I got that name from growing up in the Air Force, and my father worked for the Air Force Weapons Lab in the 1970s, and that was their tongue-in-cheek motto about what the work that they did in the 1970s was make bigger bombs for a brighter tomorrow. Today's discussion is going to go back in time a little bit more than the 1970s. I'm going to specifically talk about the American nuclear enterprise from 1945 to 1950, at a time when America had this supposedly nuclear monopoly. And with this monopoly, we could keep the Russians in check and secure world peace. And what I'm going to tell you today is that's false. We had no capability. This is largely how a lot of people thought of the atomic bomb subsequent to World War II, with the victory over Japan, with the bombs being dropped over Hiroshima and Nagasaki. But like I said earlier, this is more form than it is substance. And this problem that the American military has is not just a problem with the soon-to-be United States Air Force, it's also a problem within the civilian institutions themselves, specifically the Atomic Energy Commission, which is established after the war. And there is miscommunication, jealousies, and poor organizational structure within the U.S. government and within the U.S. military during this time. Of course, everybody in this room is probably familiar with the idea of the Manhattan Engineering District. In December 1942, Enrico Fermi has the first sustaining nuclear chain reaction, this idea of fission is possible, which you could use for a nuclear event to have an explosion. This project is eventually going to employ over 600,000 Americans, and it's going to cost $2 billion. It's the second biggest expense during the Second World War. The first biggest expense is the B-29 Superfortress bomber. That cost $3 billion. You've heard a lot of discussions over the scientists that were involved in this. The gentleman on the lower left here obviously is familiar to everybody in here, J. Robert Oppenheimer, and the gentleman on top is General Groves, who is the military commander of the Manhattan Engineering District. These gentlemen, contrary to what you may hear in the press, have no moral qualms over what they are doing. Most of the scientists at Los Alamos doing this work understand they are putting together a huge weapon that's going to kill a lot of people, but they also understand the realities of the war that the American people are involved in. There are scientists at the University of Chicago and other locations that have moral problems with nuclear bombs and this technology, but not the gentleman at Los Alamos. If I can give you a quote here from a physicist named Percy Bergman, if anyone has a sense of sin regarding the nuclear bomb, it's God. He put the facts there. If I'm going to go to hell, it's for something worse than this. So again, the development of Little Boy and Fat Man is not a moral problem, but this is a huge effort within the United States, and it's an effort that's going to atrophy subsequent to 1945. Most of you are familiar with the little boy bomb that we will drop over Hiroshima. This is it's called a gun barrel design, and if you can look on the graphic there, there's a slug of U-235. It is sent down, literally a gun barrel, into a receptor of U-235, and when these two pieces meet, you have a fissionable event. Okay? By the February of 1945, most of the scientists at Los Alamos know this will work. This is a proven design. They figure that theoretically we've done enough scientific experiments that this is a proven design. The problem is it's not a very efficient use of uranium at this time, and uranium is a very difficult substance to manufacture in 1944 and 1945. There's got to be a more efficient way to have a nuclear explosion because uranium is just too difficult. But again, theoretically, they know this will work. It's about 9,000 pounds and it's about 10 feet long. It will only fit in a specially configured B-29. Not your standard B-29, it has to be a specially configured one, and we'll talk a little about that later on. This will produce between 13 and 18 kilotons of destructive force ballpark figure. Okay. The next design that most of you are familiar with is the Fat Man design, or it's also referred to as the Mark III. This is a plutonium-based design. Okay? And you can see it's subsequently very different. Based upon an implosion. What the design is, and I am not a physicist, I'm a historian, okay? What happens is you have a core of plutonium surrounded by explosives with the beryllium initiator in the core. What happens with this implosion design is 32 separate explosives occur at the same time, compressing this plutonium core while the beryllium initiator sends out free neutrons, creating a fissionable event. This design is what takes most of the scientific effort at Los Alamos. Remember, little boy, they know pretty much will work. Fat Man is the real theoretical nut they are trying to crack. Okay? Because plutonium at this time is relatively easier to make than uranium. It's still a difficult process, but it's relatively easier to make. And as a result, you can have more bombs available to you by using plutonium as opposed to uranium. So in July of 1945, at the Trinity site on July 16th, over the PA system, there's a frequency problem, and they're also getting feedback from the Voice of America. In the background is Serenade and Strings as they're doing the countdown to the Trinity event, which is the first nuclear explosion done by man. The light can be seen up to 180 miles away, and the cloud from the destruction goes up to 41,000 feet. It leaves a crater 130 feet wide and 6 feet deep. As this explosion goes off, everybody's familiar with J. Robert Oppenheimer's quote about, I'm the destroyer of worlds. The test director by the name of Ken Bainbridge turns to one of his colleagues and says, well, we're all sons of bitches now. This implosion device will be the primary weapon that the U.S. will put in its arsenal up until 1950. This is the bomb that we have a monopoly on during this particular period of time. Near the end of 1949, we will start putting together a new device with a levitated core, the Mark IV. But during this time, this is the design that we're going to go to war with if we have a war with the Russians themselves. You can see here the picture of Groves and Oppenheimer. What you're seeing in this particular picture is the concrete base of the tower, or one of the legs of the tower that the gadget, the nuclear device, was sitting on top of. You can see it has vaporized the concrete around it. And also you can notice that Groves should probably go on the Away Control program if he was in the military today. I'll leave that one off.